Hello, good morning, and a very warm welcome to Thinking Out Loud at HOK. We're really happy to see you all here again, so many smiley faces and lots of familiar ones as well. Thank you so much for coming along. My name is Farah, and I'm the marketing principal for HOK's London studio. And so to our speaker this morning. When growing up, Adrian's next-door neighbour was a civil engineer, and what captured Adrian's imagination the most as a young boy was his neighbour was returning from trips with the most amazing curios. What does this bloke do for a living? Adrian often thought as a young boy. His neighbour was a civil engineer, and not only that, a really cool one. He had this amazing Linn record deck, which at the time was very technical, and he would play some really fantastic music. So Adrian thought, travel the world, discover new things, and play cool music. What's there not to like? His next-door neighbour did, however, suggest that Adrian take himself off to the Institute of Civil Engineers and to listen to some of the lectures before signing up. Duly inspired, Adrian went off to Southampton University to study civil engineering. Having sworn not to go anywhere near academia again, he went off to Cambridge to study for his master's in interdisciplinary design for the built environment. Adrian spent 28 years at Arup in various cities around the world, including Botswana, Hong Kong, and Cape Town, and of course, London. Adrian's portfolio includes the Gherkin, 1 Coleman Street on London Wall, Carré d'Art in Nimes, and the Health and Fitness Centre for Sky at the campus in West London. Underpinning Adrian's career was the fact that his interest was always fueled by understanding sustainable development, its impacts, and how to embed this on projects. Fast forward to now, Adrian is the founder and director of the collaborative practice titled Change Building. His passion remains structural engineering and sustainability, and his focus is on off-site systems. Ironically, Adrian has now come full circle and lectures at the University of Southampton on off-site methods and sustainable materials to a new generation of engineers. This was one of the ambitions that Adrian set out to achieve, inspiring the next generation in our industry. His current projects include the reconstruction strategy for the British Virgin Islands, arts and cultural buildings in British Columbia, Canada, and closer to home, pavilions designed for commercial redevelopment projects in Manchester. And so, without further ado, I'm really very happy to introduce the reasonably charming Adrian Campbell.
Good morning, everybody. Thank you so much for all coming out on a slightly wet day. I'm assuming that you've left your holiday plans to the weekend for your wild camping trip to the Welsh Hills when the rain comes on, so thank you for bearing through all of that and coming here today. I'd like to start by noting something which often comes right at the end of many presentations, and that's about collaboration, and people often talk about this as a solution to many of the issues in our industry. That's perhaps overly contractual relationships, not delivering system change, poor investment. But sometimes it seems like, oh, I'd love to collaborate with you if you just give me a job and I'll work on it with you. I'm very open to that, by the way, if you want to give me one. But my experience that true collaboration is really about trust and allowing someone to do something that is a little bit out of your control. So I'd really like to thank HOK for trusting me today to think out loud about off-site manufacturing and sustainability. This is a contemplation of sorts of that master's thesis I wrote at the IDB course about 20 years ago called The Lean Green Building Dream, and me thinking now what I would research if I was to go and have the opportunity to do that again. So I still have that dream that somehow we can redefine how we deliver buildings that both respond to the needs of our clients and also the broader environmental challenges that we face. I'm an engineer. I think about technical systems and solutions. But is technology, as Cedric Price would say, the answer? And the questions we answer in the industry are somehow constantly changing. So my contention is in two parts. First, that many aspects of delivery that are being discussed are now underpinned by a more advanced digital methods. It comes under many terms, but let's call that Industry 4.0. And the second, and in parallel to this, is that we've seen major changes in how we regard the environment to the point that it underpins a shift in our own values. This is remarkable. We have people voting for change in an area that has traditionally been politically very sensitive, legislating for change in people's consumption habits. Sustainable development was very much a key topic at the turn of the millennium. Despite many environmental challenges such as massive biodiversity loss, resource depletion, climate change and global heating are the main focus. And my contention is that we're at a shift from what is a low carbon economy to a limited carbon economy that has absolute, not just relative, boundaries. This will find a shift in investment and financial decisions, which will have a major influence on how we deliver buildings in the future. And importantly, and for me, as a structural engineer, will significantly impact the way that we make and use materials. So I'm going to talk about off-site manufactured construction, why I think this is heavily disrupted by digital platform methods. And I will argue that while manufactured systems can help us address the transition to a net zero economy, we need to move away from just this idea of efficiency of production to fully optimizing and embracing embodied carbon as a major factor in our building design. My career has been heavily influenced from my early career at Arup by the ideas of total design and forming solutions considering things in the round. That's not easy, given how the industry is becoming increasingly complex, but we need to think more about systems, and systems help us understand the relationships of many things to many other things, and equally, how long it takes, therefore, sometimes to make change happen. It's a bit simplistic to think that we just pull one lever and somehow the whole industry will react immediately. So as the late, great Donella Meadows would say, stocks take time to change as flows take time to flow. So forgive me this morning if I talk about a number of different topics, but I think those are all related and somehow influence construction as that total system. It's a way of me thinking about the transition from the way it is now to the way it might be and what we might have to do to get there. The basis of the talk goes back 20 years when I did the interdisciplinary design for the built environment course. That's a bit of a mouthful first thing in the morning at Cambridge. It's a great opportunity actually to find a space to think about major trends impacting construction and collaborative working practices. It's a great course, it's in its 25th year now, and a great safe space to road test new ideas. I highly recommend it. This was back in 1999. I was working on 30 St Mary's Axe, which you obviously may know better as the Gherkin. It was one of the first projects I worked on that used digital methods from end to end of the project. The geometry was generated in a spreadsheet. A very clever new graduate called Phil Mulcahy wrote a section checking script on his kitchen table to do all the steel element checkings automatically. And the analysis was optimized through that process. It used a 3D CAD program called Xsteel to provide all of the information digitally and directly to the steelwork fabricator. I was particularly interested in lean construction, how we could use these eyes to make fabrication easier. We developed ideas for the node detail, essentially to try and eliminate fabrication complexity and reduce it to 3 basic flat plates. And when I wrote the scheme design report for the project, we talked an awful lot about efficiency and optimization, but back then, we didn't really talk or have the ability to assess embodied impacts that well. So fast forward to today, and from my experience, which is probably just a polite way of saying I've been around the block a bit, my concern is we seem to be making some of these mistakes about noting the benefits of efficiency without dealing with things in a more complete way. And this is particularly true when it comes to matters of design quality and now our clear understanding of the challenges connected to the environment. Charles Eames, I think, helps a little bit here in the idea how design teams need to find an area where there's a genuine interest of our clients, the ambitions of designers and the needs of society overlap. We need to be looking at understanding the social, environmental context of our work in all of the jobs that we do. And those that have delivered most change have started with some sort of engagement on trying to understand what that is. This was no better than on the Low to No project in Helsinki in Finland, instigated by Sitra in 2009. And they conducted a large study into system change and the impacts of their society out of balance and what they could do to lower carbon emissions overall nationally by producing a new block design which influenced the master plan and might have replicable solutions which could influence their schemes nationally. So hence, it's low carbon building now to no carbon buildings in the future, hence the term low to no. This was everything from decarbonising the heat network, using informatics to influence consumption habits, working with precast manufacturers to reduce the impacts of those systems, and because 65% of the land area is covered in trees in Finland, looking at ways to optimise the use of cross-laminated timber. The block is now complete. Although not all of those innovations have been delivered, the process itself highlighted where the barriers to future replicability may be. Some of the features of the building reference those low carbon ideals in the systems, such as the castellated form of the top of the roof, which is actually based on the orientation of the PV systems on the roof of the building. And importantly, this varied architecture is made from standardized precast concrete element systems, so it's not limiting the architecture. So come back to the UK and prefabrication, it's not new to make things out of standardized components or perhaps even whole prefabricated systems. Paxton's Great Crystal Palace from the Great Exhibition of 1851 just used standardized greenhouse components to make them on a massive scale to solve the old issue of building delivery and doing that quickly. Architecture has a long history of the use of technology as a response to the issues of our time, and particularly in current living memory, post-war reconstruction. The prefab solutions are still around and much admired by many today. And, we went off from housing to more complicated flat, school and even factory solutions, to the point that they had catalogues of industrialised products like this one from 1965. It was a different time though, and we are now over 50 years on from the white heat of technology and a different need of our society today. I know there are many social environmental challenges that we face, such as massive biodiversity loss and resource depletion. However, I think it's clear now that the essential challenge of our time is climate change, and as clients, architects and engineers, we must respond to that. And I find this focus on a new urgency very telling, whether that's through the work of Climate Extinction Rebellion, or the mighty Greta Thunberg, who seems to be the closest thing that Scandinavia has to a real-life superhero, and say Marvel take note. Advanced manufacturing methods, I think, have a part of the solution in addressing this problem and accelerating that change. I'll tell you. So before I'm asked, and I'm sure I might be, this is not that we should manufacture our way out of a crisis by just making more stuff, but that manufacturing is a far better way to do the things that we need to do more effectively. That's not incrementally a little bit better. That's not just modernising a bit, but whole system change. So we got our first good realisation of limits, I think, back in 1968 in Christmas Eve when Bill Anders took this shot, the Earthrise picture from Apollo 8. What seemed like a vast, limitless system suddenly became a very small, bounded planet in the vastness of space. So we have this sense now, I think, of absolute limits, not relative limits. So this is true of the realization that in carbon emissions, to stay within either 2 degrees global heating scenarios or the more necessary 1.5 degree global heating scenarios, that we have a maximum amount of carbon that we can emit. So this will require even deeper decarbonisation to stay within those targets than that we have been used to so far. And importantly, negative emissions to capture carbon to offset those that we cannot reduce. So my contention is that this will impact all sectors going forward. So the UK has legislated emissions reduction targets to net zero carbon by 2050. Others have done it to slightly earlier dates, effectively following this 1.5 degree scenario. You noted various conversations about how this will be achieved, and that will be something that we'll have to find out. But it's clear that even with these deeper emission cuts, they'll be hard to reduce carbon emissions in various sectors. And those are maybe agriculture and aspects of heavy industry, and mass aviation perhaps as well. But materials, because they are part of that heavy industry, are a real area for us to focus on to make sure that we come within these new limit trajectories. And it's why, and appropriate then, that the UK GBC has included embodied carbon within their revised definition of net zero carbon. I couldn't really actually understand over this time why it wasn't before, but that's a different matter. So about 20 years ago, we had a rule of thumb that embodied carbon was about 10% of whole building carbon emissions. And perhaps we were talking more about energy then rather than carbon. But now, a good starting point for that number would be around about 50% of whole building emissions. So that's enormous. It's not significant just at a building scale, but also at a national scale. So about a quarter of all built environment impacts in the UK are from the use of materials. Some of you may know that I've done a lot of work since Low to No 10 years ago on mass timber systems. But it's all materials that we need to address, and I'm looking at working on strategies with the cement industry in Europe, actually, about how we decarbonise that, mainly in 3 areas, and that's production and the benefits of things like fuel switching and carbon capture and storage, design and its better use of substitution of lower impact materials, and specification, that's defining performance better. And it's these last 2 areas of design and specification about adapting ways of making things better, which is so important. So there are good reasons, I think, for us to adopt off-site methods to address this. The benefits of off-site are well rehearsed in the industry, and CIRIA, the construction industry research body, is about to do some updated work on actual metrics of this. So we have benefits of faster time, about 20 to 60% of program advantage, 90% reductions in waste, significantly improved working conditions, reduced transport movements, emissions, etc. But what's missing from those metrics is about embodied carbon. So this is a little surprising, that given the fact that off-site methods are heavily standardized and repeated systems, it's crying out for better benchmarking and ongoing optimization. If, as identified by the Green Construction Board, we want to drive emissions reduction by engaging with the supply chain earlier and build clever, off-site methods should be part of that solution. But the industry, I think, will need to develop these systems with the metrics of optimization against carbon in mind. There was a lot of talk 20 to 25 years ago on industry change reports like Latham and Egan about partnering contracts and better relationships between clients, designers and contractors. Some of that worked, but ultimately I think the idea of risk sharing wasn't that popular with many clients. So we still tend to work on single commissions with sometimes adversarial contracts. So some of the new entrants in the off-site methods are getting around all of that by simply doing everything themselves in-house and being vertically integrated. So for those interested to see how procurement's method might evolve and not actually vertically integrating themselves, what should they do? And I'm sure that for them, there are many features of the construction industry that are actually pretty attractive, and makes it often hard for them to change. So we need to consider these, I think. Those are things like flexibility and the opportunity to change through projects, and perhaps more agile manufacturing methods could help with this. Low capital investment requirements and the presumption in favour of off-site manufacturing by the government for new contracts is perhaps a way that we can offset this risk of predictable pipeline. And a known commodity for exchange. So we need to recognise that why quality and better condition and codification of off-site methods is useful in ensuring that things can be sold on in the future. And lastly, adaptability. So thinking about commodity value, we need to think about how it might be adaptable and easy to change in the future. So these are many examples of what we could do with thinking about things more as a system and the commercialization of options. So what's different now? One of the main discussions around Egon 20 years ago was the idea of adopting lean production theory that had transformed the manufacture in the car industry. We all learnt a few new Japanese words like Muda and Kaizen, and we all got a little bit leaner. We continue to focus on these technical issues, though, when we should really be looking at how digital systems are about to revolutionize construction. This is just like digital systems like Google, Facebook, and Apple iOS have disrupted our own lives. So it's not without reason that the likes of Katerra in the US have received £865 million worth of investment, and nearer to home, Goldman Sachs have invested $75 million in off-site manufacturer in the UK. These firms are developing advanced digital resource and supply chain management platforms for their own in-house use to make houses, but now are actually already externalizing those as platforms offered for others or for new projects. This is about digital and not physical platforms. So if you look at the landscape of how technology has changed, recently in property, from flexible workplaces, energy monitoring and sharing platforms such as Airbnb, you can clearly identify how this new construction ecosystem might be a major disruptor too. So here's my prediction, that digital ecosystems will revolutionize construction in the same way that data systems have shaped our lives. That's the future, I think. We already have opportunities, though, in all sorts of different solutions for projects. I don't believe that these have to be dogmatic in the way that we establish new systems. We do, however, have to be better about how we think about projects, design with systems, use more standardized methods, and understand manufacturing as a process as part of our design. The same rigor that underpins current design methodologies should underpin systems that will be manufactured. So I really enjoyed this comment from Keith Waller at the Construction Innovation Hub, summing up that ambition that we should design for everything. So that's design for manufacture and assembly, now that's for sure, but design for zero carbon, design for deconstruction and circularity, design for elegance, and so on. We can't have part solutions. So I've been helping Arup develop a new housing prototype with their manufacturing team using lightweight materials. It's not all about structure, but actually about building services that are actually a major drain on productivity and efficiency on site. So we incorporated all of the building services into a single house packaged plant unit, which we dubbed the hot box. So the whole system could be pre-commissioned, and we needed to understand how then the services would fit in a volumetric system. So we needed to change the way that we designed and what our priorities were. So if I was going to go and do that course again, and, I'm not going to do another course. I lost 2 stone doing the other one, so I'm not going to do that again. The first thing I would look at was about the way that we should simulate manufacturing design and not just represent it more digitally. So back on the WikiHouse project in 2014, for instance, we used a common and free Google SketchUp model shared between the architect and the engineer to develop the design. And then with a little bit of G-code and nesting of the panelize, it was put straight into manufacturing. So we should be exploring similar ways on projects using digital methods which include manufacturing in design at the beginning. It really should be pretty much that simple, that allows buildings to be made better with automation. So BIM really needs to be building information for manufacturing, in my view. So the other one I would look at is the impact of financial and investment methods based around new carbon pricing mechanisms. So this would give the level playing field that everybody is so eager to have when it comes to, to projects. So new research on this is needed, but I think it's really interesting that we are not going to reach the level of decarbonisation that we need without a change in these mechanisms. So we need higher shadow carbon prices or prices for carbon by manufacturers to help us with this. So I've been promoting sustainable materials and systems pretty much all my career, and the key factor that has been missing there's been little financial benefit for clients in lowering material emissions. So we need these financial impacts. So if we do have carbon pricing around 50 to 125 pounds a tonne in the future, as has been suggested, then I would be ensuring on a project that I used the least material I could, and if it was negative in its impact, like timber, I got a benefit from it. So while we need to build lighter and more efficient systems, it's actually this carbon pricing which I think would have a lot of influence. So I was pretty happy with the snappy title of my thesis 20 years ago of the lean green building dream. And so I've been wondering what it might be titled now. And so perhaps that's the green need for technology. I'm quite happy to have a beer around that with anybody who'd like to discuss that one. What matters, though, is where I started from right at the beginning of this talk, and I should end on as well, and that's the need for collaboration. To work across boundaries with new people to develop new solutions. So in those 20 years, there have been amazing shifts in technology, and I can imagine similar shifts as we adapt to what I've suggested is this limited carbon economy. It just seems to make sense to use more imaginative ways to make things, that is, efficient manufacturing methods, to help deliver the real challenges that we are to face and the real needs of society. So I suppose, in a way, we're looking for similar shifts that we've had in food and our lifestyles and consumption habits, and what construction really needs is its own version of veganism. And my contention is that manufacturing buildings might just be that. Thank you. So, questions. This is the bit I've actually been dreading.
Martin Long. I'm a Arup-trained project manager, so I suppose we have quite a lot in common somewhere in the past. What do you think is the one thing that we should take away from today, from your talk, where we could all make a difference? Because we're all probably sat here thinking a lot of what you've been talking about is aspirational, but in the worlds where we go back to today, it's very difficult to make a difference as one person, either as a project manager or as an engineer or a client. What would be the one thing at the moment that you think can change on projects which might be easier to do than some of the more aspirational things?
I know a lot of this is a provocation and aspirational, but a lot of it is realisable today. There are many examples, even from low to no 10 years ago, that were immediately applicable today. And a lot of this was about motivation. So we're very privileged to work with great clients. We are normally quite privileged to work with other great technical people. But I think it's our motivation to do the hard work and the hard miles that actually makes the change happen on projects. It's not an easy process to constantly battle against an idea to get it over the line. So I've been really lucky in my career to work with many like-minded people who share that burden to make projects work in a different way. So it is realisable. People know what the challenges are. It's just really hard sometimes to face up to constant barrage of no and get round the blockers. That would be my main thing. Don't give up.
Great talk. I think it's fantastic to hear this. What do you think are the biggest obstacles to realizing this kind of construction method? I mean, the construction industry obviously is very mature, it's well established, it's maybe not a well-oiled machine, but it's a machine nonetheless. And part two of the question, where are the gaps for realizing this? Because if you take the main contractor and they sub the various parts of construction out, are there any parts that can't be realized today?
So it's interesting. I don't think I've been around the block that long to actually see how we've allowed the industry to be fragmented into the way that it is today. So we adopt modes of designers and fabricators and contractors as parts of a system. And I think, if I could kind of do it today, I would find a different way of engaging that within a unified single process. I'm quite interested by this vertical integration model, which seems to bring all components of the industry, which is reasonably fragmented in a way, and do it a different way. So I would scrap the RIBA plan of work, I think would be my first thing to do. And stop thinking of it in that way. We need a different model of how we deliver buildings, engaging all parts of the industry as one collective whole rather than as a contractual basis. So enterprise models, which is part of the discussion about changing procurement, is very interesting. Going away from standard transactional relationships on projects to a more enterprise system where there's a relationship between suppliers and designers with clients on an ongoing basis. And I know we've done alliance contracts and everything in the past, but I would change the model of delivery completely. I wanted a slide of Che Guevara actually in this presentation to be a bit more revolutionary, but that's what I would do.
So I have a question about the chicken and egg cycle. So when we start project, usually architect works with structural engineer and civil engineer and all the other consultants. Everyone seems to wait for anybody else to suggest the benefits of material efficiency. So what is your recommendation? Are there any practical tools out there to help the team to really realize the benefits and really take responsibility on embodied carbon?
Well, not just on embodied carbon, on everything, I think. So what was fantastic about the Load to No project was the client had a rule, and that was no quick no's. So it's really easy on any project to just veto something almost immediately because you don't know. So many issues take a bit of time to develop, to understand, and that's part of the design process of going into the unknown, I think, exploring a solution and seeing if it works. So what we did on that, we had 13 points of innovation across all matters of lifestyle, structure, energy systems, taking out from just the project level to a master plan and a national level of influence. So what's the big system? Working through them. So we had an opportunity, it was a fantastic client, it doesn't happen very often, who allowed us space to explore these ideas, to see where the value was, see what the relationship was between them, the mutual benefits through doing one thing and another, and then working out what the reality of that was, the hard commercial bit about costs and program implications and quality and where was the innovation risk. So I think it's a bit like not killing off things early and not thinking and allowing things to develop. That's kind of, walking through the process a little bit. So they were really good about avoiding the quick no.
Back to manufacturing part again, because you showed us some a few slides on the digital fabrication, and the wiki house is probably the simplest form that we could find. It's kind of well demonstrated how to design things in digital platform and bring into real life. And the procurement system itself is probably the simplest and purest form that you could find. And you also mentioned about you had fantastic clients and had very, like a talented mind and a very futuristic mind. And we also discussed about the bringing the art industry, such as the car manufacturers, like you showed in one of your slides, and the aerospace industry. Have you ever worked with any of those companies or any other industry in your career or any of your projects? And if you do so, then could you tell us a bit more about those?
The housing product that we was doing is working with a manufacturing specialist whose background is in cars. Swan New Builds factory out in Essex is run by a guy who's got a manufacturing background, not a construction background. So when we were developing up that little housing model, it's amazing what he would say you couldn't do compared to what I would normally do. So you can't do that because it doesn't fit with the process flow of how I will make this. So there's enormous learning about manufacturing ways and how they influence your design decisions. So I think the analogy is back to you can have any colour you like as long as it was black, and it was black because it could only dry in a certain time. That was the only colour that would dry within the production system. So what we need to understand is what are the constraints on process and manufacturing. So I work with that guy he's got nothing really associated with the kind of traditional architecture and engineering background, but he's driving that process. So we need to understand how we work in that manufacturing methodology. It's not taking, or we should make it like ships, or we should make it like cars, or we should make it like something else. We should understand the processes that they use and how that leads to an efficient model. And that's a very different mindset from what we traditionally do as designers, I think. I've been quite shocked by that.
Shirley Waldron from Delver Patman Redler. Thank you very much for your talk. But I had one observation, and that is that it seems like only a couple of generations ago that grandparents and great-grandparents were making do and mending and getting their irons repaired. And today we see, very much a throwaway replacement society. And that doesn't just apply to household implements, but also to buildings. I mean, I'm not that old, but I have worked on buildings as an architect which have been demolished in my lifetime, which is kind of a shame, really, to that short-termism, which, how do we get back to that making do and mending in a construction way?
So it wasn't a topic specifically for today, but I think aspects of circularity and the circular economy are part of that. So the decarbonisation that we need, which is actually avoiding new emissions in the first place, is very much aligned to this idea of repairing, reusing, remaking. We call that make, do and mend, but I think that's part of that process. So yes, it's a little simplistic, the argument that perhaps I put forward today in a particular fashion, but if we are to reach the sorts of levels of decarbonisation that we want, we're going to have to avoid making stuff in the first place. So I do agree with that. How we do that is perhaps value the resources and the carbon used to make buildings in the first place. This goes back to financial metrics time and time again, I think.
Yeah, I mean, it's a well-known fact that the construction industry is inefficient. First of all, there's a lot of costs that can be removed. And actually, most of the time, that's the driver in manufacturing. Because if you build a chair, and if it costs £10 more, that equals £50 more by the time it gets to the end user. So there's that multiplication from manufacturing costs to going through the distribution channels to the end. So there's a real driver to reduce and to optimize and to make more efficient everything we're doing, shaving millimeters off of material, more efficient assembly processes, So it's materials, it's time, it's money, And that discipline actually has an impact on the carbon as well, because if you're using less materials, if you're spending less time, that whole simplification of the process, also logistics, where does it come from, shipping it from one place to another, that's a cost, that's a real cost. So in the manufacturing disciplines, there is that focus on reduction already. So when you apply that to construction, obviously that's going to have huge benefits for the environment, but also for the cost of construction. And thirdly, I think for the quality of construction, because when you spend the time to optimize details and the manufacturing, the assembly of a system, you end up with a really beautiful result, I think. And it doesn't get ruined on site because of inconsistent craftsmanship and things like that. So that kind of discipline is really useful for the construction industry. I think it is the way forward, and obviously it's not terribly new. It was done in the 60s by Charles Eames, who was an industrial designer but also an architect, and he did the case study houses, and several others did as well. Post-war thinking, which was, they really were the pioneers. In the post-war period, when resources, time, money, everything was short. So they had to be so smart about how they were building. And so they did these case study houses so they could create a new paradigm for thinking about construction, solving problems. The place we're at now, there's an urgency about the environment, and we have to solve those problems. So I think we're here again. We have to solve new problems, and we have to shift the paradigm. And I think bringing construction and manufacturing together is the answer.